This is the first tutorial under the chapter Heights and Distances, and it's a continuation of the trigonometry chapter. It's closely related. It uses a lot of trig that forms the basis of the chapter. And you can see over here, I've just drawn the table for the standard angles. I'm sure you've done this. You've done it in class 9 as well when you first did trig. So the reason I've drawn it is because in heights and distances, you're going to be using not the whole table but this section of it very often. This is the main part. If you know these, then you're not going to have any problem in this chapter. Just before you move on, learn these very well. And sine and cos, you won't come across these too much. The main one is tan, and especially these three, very important. So before doing any sum, you should memorize these. And the way to not get confused in these three over here, this is a fraction, and out of the three it comes first. So f a fraction, f a first. That's the way I memorize it. And then of course comes the numerator first, then the denominator. So 1 by root 3 fraction first, then take the numerator, which is 1, then take the denominator, which is root 3. And also, I don't know, but some of your books will probably say tangent is not defined. Some might say it is infinity, but you don't need to bother about that right now. You learn more about that next year. So right now, leave it at that. You're not going to do any numericals on that, any sums on that, because, well, you can't. It's not defined. So getting to the basics of heights and distances. Heights and distances is the chapter deals with literally heights and distances. When you have a certain object and you're looking at it at a certain angle from a certain distance, you can determine its height. That's what the whole chapter is about, and vice versa. That if you know the height and you know the angle, then you can figure out the distance. Say this is a building over here. Let's just draw a sort of building. Okay, this is a building. No, it looks nothing like one. I'm writing bill. Okay, I just hope you get the point. And if there's a person standing here, say this is the ground and a person is standing here. If he or she is looking up at this, and you know the angle that he's looking up at the building, if he's looking at the top of the building, the angle subtended by his view with the x-axis, horizontal axis, that is. This is the horizontal axis. You could call this like the x-axis, and this is his sight. This is line of sight, his view. So the angle between these two, we call it theta. And if this is the case where he's looking up, then we call it angle of elevation. Now, if we can somehow measure this angle of elevation, talking about a practical scenario here, and we can measure the distance between this person and the building, we can actually tell the height of the building using trigonometry. So that's what we're going to do right now. And also there's angle of depression. You can guess depression is like going down. So instead of the person being at the bottom, this is when you have a person at the top looking down at something. Say there's a person here, he's looking down, this is his line of sight, and say you have a car moving down. So the angle that the line of sight, which is, I should make it a different color. So line of sight, I've drawn the arrow, blue arrow. This line, the angle that it makes with the horizontal axis, we can take it like this. So this is the angle. That angle is called the angle of depression. Now if you look at it, let's just draw another diagram here. what we're saying is that let's say the one at the bottom is theta1, this is theta2, this is your building here. Okay, so what we're saying is that theta1 is angle of elevation, theta2 is the angle of depression. I should write it. So if you look at it using the properties of parallel lines, these two are parallel lines, the two horizontal axes. Uh, so if you look at it, theta1 is equal to theta2, mathematically, that is. I mean, it's not the same thing looking down from the building and looking up to the building, but their values are the same. Uh, you can see that pretty clearly. This whole thing will be 90. This is a 90. So this angle here is 90 minus theta1. Therefore, this angle here will be 90 minus 90 plus theta1. So it will be theta1, and we're calling this angle theta2. If you draw it on a piece of paper, you'll get it. I think what I just said was a bit too fast to follow, but theta1 is equal to theta2 over here. So also to use the sine, cos, tan, you just need to draw the diagram. You'll in most cases you'll be given one side. Say you're given this side over here, and you need to find out this side here. You just need to find out that out of this column here, which ratio, sine, cos, or tan, gives you the two sides you're looking at. For example, in this case, you're looking at P and B. So here it's obvious you're going to look at tan. Say you're not looking at B. Say you wanted to find H. So then you take the sine. Similarly, if you didn't want the P and you wanted a B, then you take cos. So you just need to find out which one fits in according to the sum. So that's all there is to learn. Otherwise, it's just applying your trigonometric angles, standard angles, and I think there's not much of scope for any doubt in this chapter. Maybe one or two sums, but it's all very straightforward. So I'm going to do a couple of sums. To do this chapter, there are many sums, many types of questions that can come. So I can't do all of them for you, but if you have any doubt in any of them, you can always contact us. We'll try and solve it. But here we can only do a limited number. So right now I'm going to do one from, okay, there is a question over here which says the angle of elevation of the top of a tower from a point A on the ground is 30 degrees. On walking 50 meters towards the tower, the angle of elevation is found to be 60 degrees. Calculate the height of the tower and the distance of the tower from A. So firstly, in these questions, just draw a diagram. The angle of elevation of the top of a tower from, so we know there's a tower, that's our first piece of information, and there's a point A on the ground. The angle of elevation is 30 degrees. So we know this angle is 30 degrees. This is your tower over here. And angle of elevation to the top of the tower, so over here, is 30 degrees. Next thing is, on walking 50 meters towards the tower, the angle of elevation is found to be 60 degrees. So let's say this is point A, sorry, and we walk 50 meters. That means this distance is 50 meters, and the angle of elevation that point is found to be 60. So we find the height of the tower. That's our first part. So let's just let the height be h. So the way to do this is first just let's also keep this whole line over here as x meters. So, and you know that this line over here is 50 meters. So this becomes x minus 50. And I'm letting this be x because that's the second part of the question. You need to find that as well. So all we do in these questions is take each triangle separately. I should name them. It'll become easier to explain. So it's ABCD. So now we take ACD, triangle ACD, and you can see here that the hypotenuse is this one, AD, and we really have nothing to do with AD in this question or BD. We're only concerned about AB, BC, and CD. So the ratio that we need should have P and B in it, and that's tan. So when we take tan, we know that this angle DAC is 30 degrees. So tan 30 is equal to perpendicular upon base. Now look at this whole triangle, forget the line in between. And we take looking at this angle right now. Perpendicular for this angle will be H. This line CD. Let's write CD first. Upon the base, and the base is AC. Now we just put in the values. So you get H upon X. And tan 30, remember fraction first, so 1 by root 3. And from this we get one equation. We won't be able to solve anything from here, but we'll just get that x is equal to root 3h. So that's our first equation. Now in the second equation, we need to find the second equation now. So for that we're going to take the second triangle, and we need a right angle triangle. So we're not going to take ABD. We can't really do much with it. We can't do anything with it actually. So we're going to take BCD. Now in BCD, you know that angle DBC is 60 degrees. So, and again, we need to find, we're only concerned about perpendicular and base. We don't really care about the hypotenuse BD right now. So again, we take tan. So we take tan 60 now, because the angle is 60. Is equal to perpendicular upon base. I'm going to write it directly now. So perpendicular is H, and the base is x minus 50. And tan 60 is equal to root 3. So also now you could, all you need to do is substitute the value of any one of these variables from the first equation. I think I'm going to substitute h. So h is equal to x by root 3. Now we'll just replace it over here. Let's cross multiply first. H is equal to root 3 into x minus 50. Okay, now we take this value of h, put it in over here. So x upon root 3 is equal to root 3 multiplied by x minus 50. Cross multiply and we get that x is equal to root 3 into root 3 is 3. Let's open the bracket now. So 3x minus 150. So we take this x to the other side, take the minus 150 to the other side. So we get 150 is equal to 2x. So x is equal to 75 meters. Now since we got x, we just need to find h, and for that you could just take this over here, your equation 1. So h is equal to x by root 3, and just put the value of x that you found right now, 75 by root 3, and root 3's value you just take as 1.73. 1.732. So 75 divided by 1.732, 43.30. So we take it as 43.3 meters. So this is a type of question you'll probably be asked, where you'll be given two triangles. So all you need to do is first take the bigger triangle, small triangle, it doesn't matter. Just take one triangle, and you're going to get an equation something like this. Once you get that, just put it in the form of one variable. Like here we put it in the form of h. Just put it like this. Get your second triangle. Do the same thing. So solve for the second triangle as well. And also, yeah, you need to find out what you need to really find out. Like here we said perpendicular and base, so we said we'd use tan. If it was base and height, then you'd have used cos, so on. So then just calculate from the second triangle, you'll get another equation. Then just substitute the value from the first equation over here, and you're going to get the value for one of the variables. And that's it. From then you can solve it. It'll be a linear equation. Also the root 3 and root 2. So that's all there is in this chapter. There are many more questions like this. Best way is to just do as many as you can from here. If you have any doubt, just tell us. We'll try and solve it. Tell us which book it's in, or uh, just give us a sum if you like. So that's it for this tutorial, and we'll be back with another